Welcome to Brain Vision.
Okay, so we're in chapter 38, problem 1. So it says the neutrons in a parallel beam, each having kinetic energy of 0.03 electron volts, are directed through two slits that have a distance 0.6 millimeters apart from each other. So we want to look at how far apart the interference peaks will be on a screen 1 meter away. So first we need to figure out the wavelength of a neutron, and we use that by finding the de Broglie wavelength as given by h over the momentum. Now we can also write kinetic energy in terms of momentum, which becomes p squared over 2m. If we rearrange that, we can see that the momentum is the square root of 2m kinetic energy. So let's plug that into our wavelength formula, and we see that the wavelength becomes h over 2m kinetic energy. So if we have the wavelength, we want to go back to our chapter 34 to figure out what the diffraction pattern of a double slit is. And from there, we see that we now have the equation that d sine theta is equal to m lambda, where m is the order of the diffraction pattern, or the interference pattern. And we can also write the expression that gives us the y value, which is given by y equals L tan theta. Okay. So the key here is to realize that these angles are going to be small, and if we have small angles, then we know that sine theta is roughly equal to tan theta. So from that, let's set these equal to each other. So if we have sine theta equals m lambda over d, this equals tan theta, which is y over L. So if we're trying to find delta y, or the distance to the between each interference peak, we just take n equal to 1, and delta y becomes L lambda over d. The next thing we can do is plug in our neutron wavelength that we got from the de Broglie wavelength equation, and we see this as LH over d square root of 2mk. Awesome. So now we have this in a form where we know everything. So let's plug stuff in. We have delta y here is h, which is 6.63 times 10 to the negative 34 joule seconds. L was 1 meter. It said d was the distance between the slits, was 0.6 millimeters. So 6 times 10 to the negative 4 meters times the square root of 2 times, well, the mass of the proton in electron volts, neutron in electron volts is given by that's a big number. It's like 900 mega electron volts. So let's actually do it in kilograms here. So the mass in kilograms is given by 1.67 times 10 to the negative 27 kilograms. And now we can convert our EV to joules and make everything in SI units. So our kinetic energy is 0.03 EV. Let's convert this to joules by multiplying by 1.6 times negative 19 joules per electron volt. Okay, so now we have everything in SI units because these electron volts cancel. So we can plug it in and we will get out in our calculator an answer of 2.8 times 10 to the negative 7 meters. Perfect.